So we are going to 3 voltmeter method. So same like how we calculate the resistance, here also to find the inductance we are using 3 voltmeter method. So to find the 3 voltmeter method, what are we supposed to do? We are supposed to take a resistor which is having a parallel voltmeter and which is again having voltmeters in series and which is having a supply. So usually this is the circuit we used. Now we are indicating extra to have an inductor and resistor in the circuit. So this is the extra part we have joined. So now here is the inductor, resistor, let me name it as resistor 1. There is no rule that you should make it as R1. If you want, you can make it as R and R1 also. I am taking this way, so the equation calculation will be in that way. Okay. So now these are our voltmeters. So this is V1, this is V2 and this is V3. So now what are we saying? So the inductor and resistors are in the circuit and we are going to calculate from the readings of these 3 voltmeters. So from here we can say, from the Phasor diagram, what is it? From the Phasor diagram. What do you mean by Phasor diagram? You remember we did it in the same 3 voltmeter method. So in 3 voltmeter method, for finding the resistor, we said this is the voltage V2 and voltage V3 and the resultant of these two voltages is said as V1. So from here the phi value is calculated and we said V2 is equals to IR1, isn't it? So the same thing we are going to use here. So we use it the Phasor diagram like this. V2, V3 is having a resultant of V1 and where V2 is IR1 which is having a cos phi value. So now we are using the same Phasor diagram and we are writing our equation as V1 square is equals to V2 square plus V3 square plus 2V2 V3 cos phi. From this we said cos phi is equals to V1 square minus V2 square minus V3 square by 2V2 V3. So this is what we know already. But usually we can even say that we also know cos phi is equals to R by Z. Means cos phi is nothing but the resistance of the circuit by total impedance of the circuit. What do you mean by impedance? So impedance Z is equals to square root of R square plus W square L square. Why are we writing this? From AC principles you have learned this. Impedance is equals to sum of the elements. Square root of sum of the elements. What are those? R square plus L square. But L means omega L always, right? So Z is equals to square root of R square plus omega square L square. Okay? But usually W is nothing but 2 pi F, angular frequency. So W is the angular frequency, R is the resistance, L is the inductance. So now you see, now you can say this is equation 1 and this is equation 2, isn't it? So from this equation 1 and equation 2, I want to equate the solutions. Okay. So from here, let me say my equation is V1 square minus V2 square minus V3 square by 2V2 V3, right? So cos phi is equals to R by Z, but cos phi is equals to this. So substitute 1 in 2. So when you substitute 1 into what happens? 1 is in 2 means cos phi is this v1 square minus v2 square minus v3 square by 2 v2 v3 is equals to r by z. But what is z? Z is r by square root of r square plus omega square L square. Okay. So we can say that v1 square minus v2 square minus v3 square by 2 v2 v3 is equals to r by square root of r square plus omega square L square. Simple. Just think again. What are we doing? 3 voltmeter method. So as it is a 3 voltmeter method, I am doing is I am taking 3 voltmeters, and from the phasor diagram I am writing this equation. This is known to you. At the same way, we can say cos phi is equals to r by impedance also, right? So cos phi is equals to r by z. So I substituted cos phi in this equation. So this is what I got. Now my equation is what? V by y is equals to r by r plus L. I am doing this to find the inductor. The purpose of deriving this is to find the value of inductor, means my impedance is here. So let me send it to the left side, and the left side term let me send it to the right side. So now what happens? Square root of r square plus omega square L square is equals to square root of is gone this side. So this should go this side, right? So to make it go that side, what I am doing? 2 v2 v3 will go this side. R is already there. 2 v2 v3 by this one will come this side. v1 square minus v2 square minus v3 square. So this is my equation. Okay. So to remove the square root, I am going to send this root that side. Then what it will be? R square plus omega square L square is equals to 2r v2 v3 by v1 square minus v2 square minus v3 square whole square. Isn't it? Root is gone that side. It means it will become whole square. What happens? Root will become whole square. So now my requirement is L. I don't want R. So let me send it that side. So omega square L square is equal to 2 2s are 4. 4 R square V2 square minus V3 square by V1 square minus V2 square minus V3 square whole square. Right? V3 square whole square. But R square is here. We have sent it that side. So it will be minus R square. Okay? So minus R square. But my requirement is L square, where I don't want omega. So here I don't want omega. So I will send omega that side. So L square is equals to 1 by omega square into 4R square V2 square V3 square. Sorry, I wrote it as multiple. It is a multiplication by V1 square minus V2 square minus V3 square whole square minus R square. Therefore, I can say L is equals to square root of, because square it went this side means it is root, right? So square root of 1 by omega square means 1 by, what is omega? As I said, pi omega is 2 pi f. So 1 by 2 pi f whole square into 4 R square V2 square V3 square by V1 square minus V2 square minus V3 square whole square minus R square. This is 1 by 2 pi f whole square root. So I can bring it out. Therefore, I can say L is equals to 1 by 2 pi f into square root of 4r square v2 square v3 square by v1 square minus v2 square minus v3 square whole square minus r square. This is the inductor value. Clear? So this way we can find the inductor value in a circuit. So this is how we solved. So what is it? 3 voltmeter method. In 3 voltmeter method, I mean, like, if you want to find the inductor value, you can use 3 voltmeter method. So 3 voltmeter method is like you are keeping 3 voltmeters to a resistor and you are writing the phasor diagram equation, and this is the general equation of cos phi. You substituted that 1 into, so usually impedance means the square root of some of the elements. Our elements are inductor and capacitor. So L square plus R square. L means omega L, right? So R square plus omega square L square. So that thing you substituted here, and this is how you got. After this one you got, your importance is about inductor. So inductor should go this side. So that is how inductor is gone that way. And you got this equation. From here your concentration is always to bring L out. So that's why first you have sent the root that side. So it went as whole square. Then you have sent r square minus r square. Then you have sent omega square. So 1 by omega square. Then you have sent square that side, which becomes the root. So finally this is the inductor value. Okay. Then what about the capacitor value? Okay. So usually we know R1. R1 is known value, because to this method we will take the R1 known value only. And cos theta also can be determined from R by Z. So usually what we said, R by Z is equals to cos theta, means R is equals to Z cos theta. Z means impedance. Impedance means V3 by I, right? Because impedance is the value of the voltmeter 3, because these two are in parallel. Can you see? These two are in parallel. So these two, R plus L, will give the V3 Z. So impedance means V3 means Z, V3 by I. Z is equals to V3 by I. Okay. So V3 by I. But what is I? I is equals to V2 by R1 from here. So the same thing we are writing here. So R is equals to V3 by I is equals to what? V2 by R1 cos theta. Therefore I can say R is equals to V3 R1 by V2 cos theta. So 3 voltmeter method means you are taking 3 voltmeters with a known value of the resistor. So from there we are taking the phasor diagrams and equations, and finally you are finding what is the equation for inductor L. With L we are not done, because L is in series with R also. L and R, you should find both of them, because R1 you know. If you find L and R, it means all the elements values are found out. So that's why I bought the equation for R also. So now you know L and you know R. This is what called as 3 voltmeter method to find the value of an inductor. So 3 voltmeter method to find the value of an inductor. At the same way the resistor in the circuit.